So what I want to talk about here is how to find the domain of the composition of two functions, right? And to kind of illustrate what's going on here, all right, I want to evaluate the f of g, which is what I have here, right? This is f of g at these two numbers and see what happens. All right, so let's look at f of g of -1. Now you might reasonably look at this and be a little concerned, right? Because if you look over that f of x function, it's got an x plus 1 in the denominator, and you know that you're never allowed to let the denominator be 0, right? So and that's going to happen here when x equals -1. So the domain of f is all real numbers except -1. So seeing that -1 there could, reasonably give you pause. Right, but let's see how you do this. First, I'm going to calculate g of -1. Well, that's 2 times -1 minus 3, which is -2 minus 3, which is -5. All right, so let's replace the g of -1 over here with -5, and this becomes f of -5. And look, it turns out that that isn't a problem after all. Right? F of -5 is just 1 over -5 plus 1, which is -1/4. Came out okay in the end. Right? And the reason, I want you to kind of think about this, right, is the reason because even though we saw a number that was maybe problematic, this -1 never got anywhere near the f function because it had to pass through the g function first. Right? I took this -1 and I put it into g, and it turned into something else, and that something else wasn't a problem for the f function. All right, so now let's try this again. Let's do f of g of 1. Well, g of 1 is 2 times 1 minus 3, which is -1. So let's put that in here. This is f of -1. And now hopefully you see right away, based on our previous conversation, we have a problem. -1 is not in the domain of f. If you try to stick that in there, you get 1 over -1 plus 1, which is 1 over 0, and that can't happen. Okay, so again, let's take a step back, right, and think about what happened here. This 1 looked harmless enough. 1 is in the domain of g. There was no problem putting it into here. The problem is that when it passed through that g, the output number was a number that was off limits. All right, so this is pointing us in the direction of how we're going to find the domain of the composition of two functions. All right, there's a procedure, and it looks like this. All right, first, exclude any values that make g undefined. This is just straight up, look at the g function, figure out what its domain is. Right? Any numbers that you can't put into the original g of x function cannot be part of the domain. All right, then step number 2 is look at the f function and see where the f function is undefined. Right? Then what I need to know is what values of x make the g function equal to that number. Right? And those are the numbers that are going to go out of my domain. All right, so let's try this out. Right, first, step number 1, the domain of g is all real numbers except 2. 2 makes its denominator, the denominator of the g function, 0. The domain of f is all real numbers except -1, because -1 makes the f function's denominator 0. Okay, so now how do we find the domain? All right. Well, first we have to exclude 2. That's step number 1. Right? 2 makes the original g of x function undefined. It's got to go. All right. Now, remember we're talking about the composition f of g of x. And we're not allowed to put any number in here. We're not allowed to put -1 in there. right? So in other words, this g of x piece cannot equal -1. Well, when does that happen? Well, take the g of x function, 1 over x minus 2. When does this equal -1? We're going to clear the fraction here. 1 equals negative x minus 2. So that's 1 equals negative x plus 2. So x is equal to 1. Right? That is a number that is not part of our domain. In fact, you can go ahead and write it that way if you like. You can make these not equal all the way through. Right? Then you really see clearly, okay, so x cannot be 2. We determined that already over here. And x cannot be 1. So I would say the domain of the composition is all real numbers except 1 and 2. All right, so we got another example here, and you can pause this if you like, if you want to work through this on your own, right? And then start it up again, and we'll go through it together. Okay, so start with the individual domains, right? The domain of G is all real numbers. There are no exclusions from the G function, and that's fine, right? That's fine, that's going to happen. The domain of the F function is all real numbers except -1, since -1 makes the denominator of f equal to 0. That's not allowed. All right, so now how can we find the domain of the composition? Well, step number 1 says rule out all of the numbers that aren't part of the domain of G. Well, the domain of G is all real numbers, so we're not losing anything off of the G function. We are, however, losing something off of the f, because we're talking about f of g of x, and this thing in here cannot be allowed to equal -1. All right, so again, that means g of x is not equal to -1. G of x is 2x minus 3. Move the minus 3 over. 2x can't be 2. X cannot equal 1. So now I have my domain. Right, the domain of the composition is all real numbers except not -1, sorry, except, I was looking back up at my domain up in the first part. This is all real numbers except 1. Right, anything else is fair game. All right, so again, I've got another one here, and this one is a little bigger, right, a little bigger. So again, go ahead and pause if you like. Try to work this out and see what you come up with. All right, so the domain of G is all real numbers except 0, because 0 makes that denominator 0. Now, how about F? What is the domain of F? Well, when is that denominator equal to 0? X squared plus 3x plus 2 equals 0, and this factor is just going to come out nice here. X plus 2 times x plus 1, which means we're getting two numbers, -2 and -1. So the domain of F is all real numbers except -2 and -1. All right, so we're gonna take the same approach, right? The domain of my composition. First, I have to exclude 0. All right, so just hold on to that one. Then I also have to exclude any numbers that make g of x equal to -2 or -1. So now I have two things I have to solve. I have to do g of x can't be -2, and g of x can't be -1. All right, so let's see, that's 1 over x is not equal to -2, which means x is not equal to -1/2. And 1 over x is not equal to -1, which means x is not equal to -1. And now I have my 3 excluded values. So the domain of the composite, other way, sorry, f of g. If you did it the other way around, you get a different answer. The domain of f of g of x is all real numbers except -1, -1/2, and 0. All right, so we're almost ready now to take the next step and start talking about inverse functions. But inverse functions are a little interesting in the sense that not every function has an inverse. All right, so only a certain class of functions does. Only functions that are called one-to-one have inverse functions. So before we jump into that discussion of inverses, first we're going to take a quick diversion and talk about one-to-one functions so we know which functions have these inverses and which ones don't.